What we want to look at today here is the study guide, and I won't actually, but on the study guide, I only went up to the root test, right? So your test 4 is only going to go up to what? The root test. But on your final, you're going to start to get the what? Power series here. So this isn't even going to be on your homework for homework 4. Okay, but it's going to come up for homework 5 here. So power series. Now, you might say, what in the world is a power series? Well, it's a series. You've already seen some. It's a series, and I should have put that on your study guide, in all honesty. I might change your study guide, but you guys have seen power series before. You say, what do you mean? Anybody remember something like this? So you guys know what I mean? Well, let me give you a definition here. I'll bring it back. A power series, by definition, is any series that looks like this. So this is going to be one definition of power series. You say, what does that mean? Well, you got C naught plus C1 x to the first power, C2 x to the second power, and so on here. Okay? What it is, it's a series that involves a variable x. So this is going to be a big deal with what we deal with next week. So I want to give you guys some examples of that and some definitions because it is a very big deal. And as you guys can see here, here's your variable. And so on. Then the next one will be C3, X3. Okay? And generally speaking, for a power series, here's the big question we want to know. For what x do we have convergence? You now have like a variable series, right? You got a variable series, power series. For what x do you have convergence? So this is a definition of a power series. You also have, by the way, another similar definition. Say that looks like this, and you say, what is this one? We've seen these before. I'm going to remind you guys. You have Cn x minus a to the n, where now, if you start to look at the terms, at C naught, C1 x minus a to the first, C2 x minus a squared, C3 x minus a to the cube power. That'll go on forever here. Okay, you still get the variable there, but this is now a power series about the value a. So you say, what is this? Well, it's a power series. It involves the variable x. But it's the power series, sometimes they say about a or around a. A is a constant. And we've already seen those. Okay? So this is what I'm saying when I'm thinking about this, like, I think I should have put that on your study guide. And you go, yeah, so maybe when I get home, I might even change that or modify it. I don't know. Here's what I mean. Recall. What are the terms of this series here? You guys remember the terms of this series? What's this going to be? say, oh, that's x naught, x to the first, x squared, and so on, right? That's going to be 1 plus x squared. Does anybody know where I'm going with this? Have you ever seen this before? Say yes. This was an example of your what? Of your geometric series. These are the very first series that you guys have ever seen. The very first series you've ever seen. And remember what I said. What do you really care about? You care about the values of x for which you get convergence. So, geometric, AR squared. Is that right? So, isn't A1 AR is x? What does that mean? That means 1 times r is x. That's r is x. When do you have convergence for a geometric series? When the absolute value of r is less than 1. Well, in this case, what is r? X. When do you have convergence? When the absolute value of x is less than 1, which means -1 is less than x, which is less than 1. That's what we care about, ladies and gentlemen. This is what we're looking for. Okay, we care about the values of x for which this series, what? Converges. It's called a power series. It's a variable series now. And remember this question too? We gave you guys this question here, right? They give you x minus 1 squared, to the nth power. This is another geometric series. Should be on your homework. In fact, when I get home, I know for certain I'm going to change that study guide. Because we looked at this. This is related to the direction we're headed. Okay, you guys see what I'm saying? Now, remember this. This was the terms x minus 1 to the 0 plus x minus 1 to the first, x minus 1 squared. This will be x minus 1 plus x minus 1 plus x minus 1 squared, and that goes on forever. Okay? So you have our A, this is AR, this is AR squared. This is a geometric series. So if A is 1, AR is x minus 1, doesn't that mean 1 times r is x minus 1, or my radius is going to be what again? X minus 1. When is your geometric series convergent? Do you guys remember? When the absolute value of r is less than 1. Is that right? Okay. What does that mean? The absolute value of x minus 1 needs to be less than 1. That's when you have convergence. But you're looking at the definition of an inequality, right? This is -1 is less than x minus 1, which is less than 1. And then you add 1 to the middle on the right and the left, you get 0 less than x, which is less than 2. So for these values of x, and this is what we're looking for, this particular series, which is geometric, will converge. So didn't we look at those examples? And it was on our homework. These geometrics, they really gave you power series. So they intended to ask you these questions eventually. In fact, I remember one of them, maybe it's x plus 2. Another what? Geometric series. They want to know, for what x do you have convergence? All right. So say for what x do we have convergence? Well, look at the terms. This is when n is 0, n is 1, n is 2, and so on. So 1 plus x plus 2 plus x plus 2 squared. That goes on forever. A, AR, AR squared. What is A? 1. What is AR? X plus 2. So if A is 1, that's 1 times R is x plus 2. And the radius was x plus 2 now. So we actually did this kind of question too before. If you guys remember, we actually did that one. When do you have convergence? When your absolute value of R is less than 1. So in this case, R is x plus 2. You have convergence when the absolute value of x plus 2 is less than 1. That means negative 1 is less than x plus 2, which is less than positive 1. So now if we add 1 to the left, the middle, and the, I'm sorry, not add 1, I apologize. If we subtract 2 from the middle, the right, and the left, you're going to get negative 3 less than x less than negative 1. These are the values of x for which you have what? Convergence. So now, ladies and gentlemen, let me give you guys some more notes and some more facts here. This is what we're going to look at in our future. So generally speaking, in our future, this is a definition, this is the general definition of a power series, right? And it's a power series about a letter A or a value A. A is a constant, so we have this power series. So we have the following facts. Number 1, and remember, you say, what do I care about really for a power series? We care about what values of x do we have convergence? Well, for what x do we have convergence? Well, here's what we're going to do. Here's the fact. Here's what you guys are going to look at in our future. Fact 1. Either the series would converge at a point. Converges at the point A. It's kind of like a trivial solution. So it converges at A. That means the value of x is A. So notice what happens if we plug A in here for x. If we let A, we get that trivial 0. If we add zeros forever, the sum is 0. This is like a trivial solution. Okay, x is A. Yes, you get convergence. That's finite. Okay. Or the series will converge. We say for all x. You say, what do you mean all x? X is any real number. So what you can have is that x value for a power series can be any real number. It converges for all values of x. Okay, so I can put any value of x in any value there. For x, not just x is A, but any real number, you'll have convergence. So this is what we're going to see. We had 3 possibilities. The third possibility, the series will converge in an interval. Now, we've seen this. I'll say an interval I. So you either converge at a single point, you can converge for all real numbers, or for x values in an interval, right? You see this? This is a what? Interval of convergence. It's your interval for this particular power series. You see this? This is the what? Interval of convergence. You see this one we started with? This is the interval of convergence. Okay, so every power series will converge for one of these three situations. Now that interval I, if you really looked at the details, that's from -1 to 1. This is interval notation. Okay, that's the notation you try to get people to learn in intermediate algebra. That's -1 to 1. Those are open intervals. This interval is described as 0 to 2. Interval notation. Do you guys remember that? It's even in pre-calculus. This interval will be what? -3 to -1. And I want to go back and really mention to you guys interval notation, right? This we're going to see interval notation like this here, okay? So I'm going to put a note about the type of solutions that we will see with interval I here. I'll put a note. I can look like this. Your interval can be like this. Okay, those are what's called open endpoints, where A is less than X, which is less than B. This is the one we've seen so far with the geometric series. All right? So there's a little bit of details I wanted to get started with to get out of the way. You also will see intervals that look like this. A to B, where one endpoint is inclusive. You say, what does that mean? A is less than X, which is less than or equal to B. Easy peasy lemon squeezy. The last interval you can see is, well, not the last one, A to B. Now you include the endpoint A, but not the endpoint B. So this is the meaning of those particular intervals, okay? Do you guys remember this kind of notation here? Maybe from pre-calculus, I hope. And then what could you see here? What's the last thing you can see as an interval? You include both A and B. So A is less than or equal to X, which is less than or equal to what? B. So, ladies and gentlemen, this is where we are at. These are all the interval solutions you can see. And again, I keep saying 1, 2, 2. Jeez. I'm glad I'm going to the doctor. I'm going to ask the doctor today. Sorry, I don't have office hours today, so let you guys know there's a department meeting, and then I have a doctor's appointment I got to get out to. In fact, I have a doctor's appointment tomorrow, too. It's horrible. That's what happens when you get old. You get more than one doctor. So this is where we're headed. We're gonna care about these are known as, by the way, I is known as your interval of convergence. So it's an interval of convergence for a power series. Now, I don't know if I have time for an example. But let me try one here. This is what's coming for us, ladies and gentlemen. Oh, I'm sorry. Did I miss your question there, Blanca? I'm sorry. I'm sorry, Blanca. No, I'm no office hours today. I apologize. It's a quick department chair situation meeting that we're having a new chair. He's leaving, and well, he's not leaving. He's no longer chair, and so they're gonna have a meeting about that. And also, I got to get out to the doctor today and tomorrow, so it's horrible. It's just regular doctor stuff. It's nothing concerning. So let me give you guys an example here, okay? This is a power series. Okay, do you guys see the variable x? You go, yeah, I see the variable. So that makes this a what? A power series. Okay? So what you're going to do now with this power series, okay, they're going to know for what x do we have convergence. Here's your AN. So you might say, what do I do here? Here's what you guys do here. Use the ratio test. Absolute value of AN plus 1 over the absolute value of AN, right? So we say, what is that? Well, AN is x to the n over n 3 to the n. So that means AN plus 1. Change n to n plus 1. Okay, you guys okay with that? So you say this is going to be x to the what? N plus 1, n plus 1, 3 to the n plus 1. Now multiply by the reciprocal, save some time. That's n, 3 to the n, x to the n. Okay? So remember, by the ratio test, you do some algebra, properties of exponents. That's x to the n times x and 3 to the n over n plus 1, 3 to the n times 3 times x to the n. So I just use properties of exponents there, right? Is that true? Do you guys know what I'm saying? Now the fun begins. What do we mean by the fun? What goes away? X to the n, 3 to the n. Anything else go away? No. Looks like we have x, n, n plus 1 and 3. Okay. Every detail. So here's what I want you guys to notice here. Okay? Again, by properties of absolute value, the absolute value of a product, or the quotient, is quotient of absolute values. I'm going to put my 3 first. Absolute value of a product is product of absolute values, okay? So I'm using my absolute value rules. Is that true? Do you guys know what I'm saying? We're using that. So I want to remark. What's the deal? N plus 1 and 3, aren't they all positive? You know what that means? I can get rid of the absolute values. So that's why I have this. Absolute value of x times n over 3 times n plus 1. This is what I have to take the limit for. Okay? This is what I'm going to do. You guys okay with that? Isn't this the ratio test? So this is why you want to study the ratio test. Okay, this is going to take you a long way. Okay, so that limit is what we're looking at. Okay, so this is limit as n goes to infinity, absolute value of x, and 3n plus 1. So ladies and gentlemen, let me point out an extremely important detail. This is the limit for n. Is that true? What that means is you're free to think of the absolute value of x and 3 as a constant, because the limit applies to n. So pull out what? Pull out the absolute value of x, pull out the 3, because they're constants. And now you just have to take this limit here. Do you guys happen to know what that limit is? What's this limit as n goes to infinity? This limit is what? 1. Outstanding. So you say, Mr. Judge, is that the absolute value of x minus over 3 times 1, which is the absolute value of x over 3, isn't that less than 1? If it's less than 1, what do you guys know if this thing is less than 1? What do we have? It has to be smaller than 1 to have what? Convergence, yes. So what equation is this? If I multiply both sides by 3, the absolute value of x is less than 3, which means negative 3 is less than x, which is less than 3. Now, so far, these are the value of x's in which you have what? Convergence. But you're not done, ladies and gentlemen. You're not done. So I'm going to write that down. We are not done. So go back to this situation here. Okay? What happens this is what you need to have convergence. What happens if that limit is bigger than 1? Well, you have divergence. Is that true? But what really happens if that limit equals 1? Do you guys remember that? What did that mean? That was the in what? Conclusive. What does inconclusive mean? It means you can't conclude. It may converge, it may diverge. So what does that mean as an equation? If I multiply both sides by 3, the absolute value of x is 3, which means either x is 3 or x is minus 3. Okay? See my point? This is the inconclusive situation of the ratio test. If that limit is 1. Now, you might say, what does this mean, Mr. Judge? You guys know what it means? We got to go back to the original series here. This is what this means. Bless you. Go back to the series. Because this is when it's inconclusive. You got to go back and plug what? Plug in 3 for x. So this is 3 over here. You're going to let x be 3 now. That gives you 3 to the n over n times what? 3 to the n. Doesn't this cancel? So when you let x be 3, because it's inconclusive, you get the harmonic series. This what? Diverges. So we know we cannot include 3 in this interval. Okay? X cannot be 3. But if I plug in negative 3, plug in negative 3, we get the series here. Negative 3 to the n and 3 to the n. Do you guys know what that gives you? You might have seen this before. This is negative 1 to the n, 3 to the n over n, 3 to the n. What goes on with this series? Does anybody recognize this series? What is this series? This is an alternating series. Is that right? What do you guys know about this particular alternating series? What do you guys know about this series? Anybody know anything about this series? Does it converge? Converges by the what? By the alternating series test. So what that means is you can allow x to be negative 3 and you have convergence. What that really means is the interval of convergence includes negative 3 but does not include positive 3. So they're going to ask for the interval of convergence for your power series, and these are the values of x for which you have convergence. Now, here's what I want to say. On your test, what do you think you're going to be asked? Do you know the alternating series test? I hope, because you can see them with power series. Do you know the harmonic series diverges? Yes, you use the integral test. Do you know the algebra behind the ratio test? And the fact that if it's less than 1, you have convergence. If it equals 1, inconclusive. If it's greater than 1 or infinity, that's divergence. So the reason you have all those various tests to study and review is because you can see them with what? Power series. Are you going to see power series in the next test? No. When are you going to see it? Final. So you guys see my point? I wanted to present that to you guys, that power series is on deck. But if you're going to be successful with power series, you got to be successful with all those other tests that we did. Here's your interval of convergence. Anyway, it's on deck. All right. Did we give you guys your homework already? Right? Let's look at ratio and root test. We started to talk about these power series. Do you guys remember? So I introduced this information to you guys already. Power series, okay? So we gave you the definition. This is your definition of power series right up here, and it's centered around the value A. And then we want to know for what values of X, for what X, these values, do we have convergence? Okay. So we already had a good start on that. And we showed that you can converge at a point, you can converge for all X, and you can converge over an interval. But the interval of convergence can have some open endpoints or closed endpoints or a combination. So we really want to look at this interval of convergence when there is an interval. Okay, so that's kind of where we're at. We went through the first example of a power series, and we showed that by using the ratio test, we showed that that interval was absolute value of X less than 3, and then we had to look at the endpoints, because where it equals 1, that absolute value of X equals 3 is 1, it was inconclusive by the root test. So what you do is you go back and you check the endpoints, and when you check the endpoints, that's when you're going to have to look at the various series that you guys are tested on today, right? Those kind of things. So, in all honesty, that's when it's going to start to work now to see, can you do regular, I should say, series convergence or not? And that's what's going to happen now. So I wanted to introduce that so that we can now start to look at some other examples of this ratio test and go over those 3 criteria. So that's what I planned on doing today. So anyway, and like I did before, I sent you guys some links over additional examples if you wanted to see those. Did you guys ever look at those examples? Just curious. Anybody look at the additional examples? So I hope you guys find them helpful, because that's how you do things. Yes.
The examples were in your website, right?
Yeah, they're on the website. Yeah, they're all on my website. Yes, and there's actually 2 pages. One's the online notes transition page, and then the other one is the video and worksheet page. They're the same for the most part. One has additional notes, one doesn't, but they're the same videos, essentially. So just want to let you guys know I've been sending you both. But okay, so let's look at another power series example, since this is going to be on your what? Final. Here's AN. So here, AN looks like this. Okay. And again, what do you guys think you want to use here? You want to use the what? Just like you did before. The ratio test. So this is going to be using the ratio test. And we want to find the values of X for which you have convergence, because there's a variable now. Right? So what would that look like on the ratio test? You have what? AN plus 1. If I change my N term to N plus 1, right? That just changes wherever there's an N. It's now N plus 1, right? And so now, again, you take the ratio of AN plus 1 to AN, and that'll be N plus 1 factorial X to the N plus 1 over the N factorial X to the N. Right? So this is the ratio test. Now, remember now, what do you guys want to use here to simplify what's under the radical? You want to use what? Algebra, is that right? And the definition of factorial. So what do you replace N plus 1 factorial with, right? N plus 1 times what? n factorial. What about the algebra here? Isn't that x to the n, x to the first power? Then you have the n factorial x to the n here, right? So what happens now is you get to cancel the n factorials and the x to the n, and what you're left with is the absolute value of n plus 1 times x. Okay, so if you guys, are wondering about the algebra, b to the n plus m that I'm using is b to the n times b to the m. That's the algebra that we're using. That's beginning algebra. And then here, we always use properties of absolute values. So the absolute value of a product is product of absolute values. So now this becomes the absolute value of n plus 1 times the absolute value of x. And then what do we use here? Do you guys know what we use here? We use the definition. The definition of an absolute value. And the definition of an absolute value, the piecewise definition, is what you guys see here. Okay, so what happens now is because what's under the radical, what's in the absolute value is a natural number, we just get rid of that absolute value sign. Okay, because it's positive, so you're using that logic here. So this is what we just found. This is what? The absolute value of the ratio. And that's what you're going to have to take the limit now of. So you say, okay, the limit of the ratio here, right, is the limit of n plus 1 absolute value of x. Now this is what you guys want to do here, okay? This portion here you can think of as a constant because the variable you're trying to take the limit is for this n here. So what you do is you take out your absolute value of x now. And then that's now going to be here, this particular limit here. All right. Okay, so is everybody okay with that? We took this out here because limit as opposed to it applies to the n variable. So now, ladies and gentlemen, you might say, well, what do you do with this? What does this mean here? Okay, and I want you guys to kind of be careful with this. I want you to note a few things here. You can say that this limit is going to be what? Infinity. Is that true? How do you guys know that limit's infinity? Where does n plus 1 go to? That go to infinity? But you have to be careful. This assumes if x is a non-zero number, right? So if this x is a non-zero number, then you have this limit going to infinity, which means you have what? Divergence. Is that true? But what if x equals 0 now? Then the absolute value of 0 times that limit here, go back and put that absolute value here. Let's go back here. If that is 0, here's what I want to go back and note here. That you're now really looking at the limit, if I can get the highlighter, n plus 1 the absolute value is 0, n goes to infinity. What is this here? Do you guys know? Isn't this 0? So this whole thing is actually the 0 sequence. The limit of a constant is the what? Is the constant. Now that number is smaller than 1. And what does that mean by the ratio test? You guys remember? Yes, you have what? Convergence by the ratio test. This is the stuff you would have a test on today. So this is why I wanted people to study that and be familiar with that. You got convergence. That's going to be the constant sequence of 0. Okay, so you say, what does that mean in conclusion, right? So you say, what's the conclusion here? Well, remember, we're trying to find the values of x where you have convergence. Okay, so you have convergence only when x is what? When x is 0. Is that true? This is where you have convergence, when the set of values x is 0. So go back to the statement that we talked about here, right? What do we say we're going to have here? You can converge at a what? At a point. That's what we're talking about. You converge for a single value of x. Yes? Right, let me go back here. So last time we seen an example where this is valid. Is that true? We had an interval. Now we seen an example where you converge at a single value here, a. That's what I'm getting at. We're going to see now an example where the series what? Converges for all real numbers. So you guys can see an example. But you had a question. The question is, if you scroll down here. Right. Factorial. Right around. Okay, so here's kind of the question here, right? The question really is the other one. Right here, this n factorial? Well, that's related to what I'm saying here. Okay, remember what's the definition of factorial? You guys remember? Right, factorial, this is the definition. You start at n and you start counting backwards. You got a 2 times 1. And it's repeat multiplication. But if you start at n plus 1, you say, how does that work? Well, you start at n plus 1, and then you have n minus 1. You just keep counting backwards forever. So you might say, well, wait a minute. Isn't this portion the definition of n factorial? And it is. So I can write n plus 1 factorial as n plus 1 times n factorial. Now you might say, why do I want to do that? Because if I do, what do I get? The nice cancellation of factorial. And that's something that you're going to see over and over again with factorial. Because you're going to see a lot of factorial here for some of these kind of questions. Anyway. And then, where am I looking at here? Okay. It's kind of weird. All right, let me get an example here. I was trying to find one. It's odd. Okay, let's try this example then. Okay, another power series representation. Okay, the variable x. I want to know for what values of x you have convergence here, right? So here's again, what are you guys going to use again? This whole thing is going to be your what? an, negative 1 to the n, x to the 2n over 2n factorial. So this whole thing is your an. So what's the next term, an plus 1? What is that next term? You're going to have what? Replace your n with n plus 1. That's 2, n plus 1 factorial. Now, I think you probably want to do a little simplification here, right? In other words, isn't this power going to be 2n plus 2? And this will be 2n plus 2 also. Okay, so you're going to use again the what? You're going to use your ratio test. So you're going to take that limit by the ratio test. You take the absolute value an plus 1 over an. So remember what I do whenever I have a fraction to save some time here, right? What do you want to do to save some time? You multiply by the what? Reciprocal of an right here. That's the same as dividing by a fraction. So what's the reciprocal of an then? Isn't that going to be what? 2n factorial. So it looks like this is 2n factorial as a numerator. Right? And negative 1 to the n, x to the 2n. So double check. So what do you guys think you want to do here in this problem? Right? Isn't this negative 1 to the n times negative 1? Aren't you going to do algebra here? And what about this algebra? What's that going to be? The x to the 2n times x squared. Properties of what? Right? From beginning algebra. And you get 2n factorial over. Now I'm going to put this here, negative 1 to the n, x to the 2n here. But what happens down here? What do you guys think happens there? Anyone know? What do you think is going to happen there? What's the definition of factorial? Right? What do we just get through? Start with the number 2n plus 2 and subtract 1. Count backwards. You're going to now have what? 2n plus 1. And then you're going to have what? Could I say 2n factorial? So I don't have to count backwards forever. So why do I want to stop at 2n factorial? Cancel out right here. Is that right? So then the rest is like some nice cancellation. Negative 1 to the n. I got an x to the 2n. And I think that's pretty much it, because what's left now is negative 1 x squared and then these terms here. Now, again, by properties of what? Absolute value here. We could take the absolute value of a quotient, absolute value of a product. We're really taking the absolute value of every term, right? And what's the absolute value of -1? That's going to be what? +1. And then you say, well, what's the absolute value of 2n plus 2? Well, I can just say that's 2n plus 2, right? Maybe I want to use my purple if I'm using some past, I don't know, algebra. This is 1. Definition of absolute value, because we're talking natural numbers now, okay? The only thing you probably are going to remark about is what do you do with this x squared here, right? Say, what happens with this, algebraically speaking, right? Well, by the product rule, you simply pull out the power, right? So altogether, you have that absolute value x squared essentially over 2n plus 2, 2n plus 1. Okay, so we're just using those algebra properties now. You'd have to take the limit as n goes to infinity, an plus 1 over an, and you don't forget you have this absolute value of x to the second power over the 2n plus 2, 2n plus 1. This is as n goes to infinity. Now again, you got a nice constant here because the limit is about what? N. So I can pull out, again, the absolute value of x squared times the limit, n goes to infinity. That'll be 1 over 2n plus 2, 2n plus 1. So what does this limit here go to? Right? You guys took calculus 1. What is this? 0. Is that true? Okay, now this is 0 for all what? For all x values. Is that true? So you say, what are you talking about? It doesn't matter what x is. That limit's still going to be what? 0. Is that true? So if you say, what if x is equal to 0? Well, that limit is 0. What if x is not 0? Well, that limit's still 0. So this limit is 0, which is smaller than 1. And what does any limit that's finite smaller than 1 by the ratio test mean? Right? So this whole thing equals what? Is what I'm saying. This is 0, which is less than 1 for every x value. What does that mean by the ratio test? What does that mean? That means the series what? Converges by the ratio test. So if it converges by the ratio test for all x, what do they mean by all x? That's every what? Every real number. And sometimes you see that this way. All real numbers. Okay, in interval notation. So what we've seen is the examples where all three situations, right? We've seen where the answer is an interval. We've seen where the answer is a what? This is our conclusion here. Let's go back. We've seen power series converge now for all of these what? Situations. Those are all the different types of answers that you can get for power series convergence. All right, let's take a look at some more examples here. Let's see, did we do one that looks, do we do this? How about this? X to the n over 5n, n to the fifth power. So which test you guys think you're going to use, ratio or root test? Ratio or root? Here's our AN. You're going to use again what? Use ratio test. Okay, why not root test? You have to have a pure nth root for all terms. So if you don't, it's going to be the ratio test. So you're going to use ratio test. Okay. So in that case, if you said, you know, Mr. Judge, how do I get faster with these? Well, you practice number one. Number two, what you can do is just start up from the beginning, am plus 1. So you say this is x to the n plus 1 now. Change the term to not n, but n plus 1. And then multiply by that reciprocal of an, which would now be what? 5 to the n, n to the fifth power, x to the n. Okay, this is what you can do to get what? Faster. Now, by the algebra, beginning algebra, x to the n times x, 5 to the n, n to the fifth power, 5 to the n times 5, n plus 1 to the fifth power, that's x to the n. So when you cancel, you go, oh, I get rid of my x to the n's. I get rid of my what? 5 to the n's. And it looks like that's it. You might want to go back and see what's here. X, n to the fifth power, 5, n plus 1 to the fifth power. So what do you think you're going to end up with now if you use those properties again? Right? Properties of absolute value. Don't you get the absolute value of x, n to the fifth power over 5, n plus 1 to the fifth power? Because all of these terms here are what? Are positive. You just don't know about the x value. So that's why you have to keep the absolute value. Right? So double check. Isn't that a lot quicker? That's a little bit quicker. Is that right? So now when you say, I have to take this limit, what do? Right? You now have n to the fifth power, n plus 1 to the fifth power. This is a limit for n, so what's the only thing that comes out as a constant? Just the what? Absolute value. And actually 5, I apologize. So you can take those constants out. You think of that as a constant because the limit is about n going to infinity. So this is n to the fifth power over n plus 1 to the fifth power. So where does this limit go? Does anybody know? That goes to what? That goes to 1, isn't it? right? Isn't that go to 1? You can say, how do I know? Calculus 1. Calculus 1 or even what? Calculus 2, Lapido's rule. This limit's 1, is that right? Okay, so that means we have the absolute value of x over 5 times 1. This needs to be smaller than 1 in order to have our what? Convergence. Is that right? So what that means is you have this equation, or sorry, inequality. It's an absolute value inequality. Multiply both sides by 5. And then what's this the definition of? Isn't that the definition of x being between -5 and +5? Right? All right. So what do we do with this now? What do you guys think? What do we see on Thursday? What now? What do we have to check? Right? Because remember, what did you guys use? You used the ratio test. So by the ratio test, you had the limit of the absolute value of the ratios. If that equals 1, what does that mean? The test is what? Inconclusive. So you say, well, what does that mean then? Well, this is when you have convergence. And I'll leave that here. But what happens if the absolute value of x equals 1? So the absolute value of x is 5. That means x is plus or minus 5. Is that true? +5, -5. These are the endpoints you guys have to check. So you might say, what do I check? I check when x is 5. I also check when x is what? -5. So you say, what do I mean? What do I check? You got to go back to the original series. Okay, so this is how you check your endpoints. Plug those in. One to infinity, this is 5 to the n over 5 to the n to the 5th power. Over here, I have what? 1 to infinity, -5 to the n, 5 to the n to the 5th power. So again, just using algebra, what do you end up with? You have to know, what is this? What is that going to be? Well, what kind of p-series? It's a convergent p-series. So we know this thing converges. It's a convergent p-series. So in other words, that happened when x is 5. So we go back and we include that value for our interval of convergence. Now, what about over here? What does this give us? Do you guys know about the algebra over here? Isn't this going to be, right? Let me look at that numerator, algebraically speaking, right? Let's look at some algebra. That's -1 to the 5th power times n, which is -1 to the n, 5 to the n. Okay, so let's ask you guys this question here. What is this? What about that series? Let's say you had your test today. What would you guys say? What is it? What do you guys know about this one? See, this is what I'm saying. If you had your test today and they gave you this, what would you say? Doesn't this converge? How do you know that converges? Anybody know? What do you have to say? Don't guess. You can't guess. I'll mark it wrong. I guarantee you it'll be wrong. You have to give the right justification. What is it? By what? Alternating series test. Is that true? Does that converge by the alternating series test? Oh, we should have had the in-class test today. Nice. I should never have done the traveling I did. See who the true believers are. Ooh. Man, I regret doing that traveling. I want to find out who knows alternating series test, right? So what does that mean? When x is -5, what do we know? We include this. Our interval of convergence is going to be what now? Right? They're going to want to know that interval. Isn't that from -5 to +5? You're including those values. So there's your answer. This is your interval of convergence, ladies and gentlemen. Yes.
Would it be wrong to us, or would it be wrong for us to assume that we're going to utilize AST if we end up with a -1 to the n power?
Say that again?
Would we be wrong to assume that we're using AST, alternating series test, if we see a -1?
Well, if you see an alternating series, I would suggest you use alternating series test. Does that kind of make some sense? I don't know. If you see an alternating series, I would plug it into the alternating series test criteria. Is that right? Right? Did you guys do homework on? If I check your homework and you did everything, because remember, what do people do? They copy from the book, or they copy from a solution manual and they turn it in, and their homework is like perfect. Perfect. And then they take a test, they can't do it. You could give them the same questions. Can't do it. You're like, how come you did it on your homework but not here? Like, ran out of time. You guys know what I'm talking about? Mr. Judge wasn't born yesterday, trust me. He's been teaching calculus for over 25 years. He's seen it all. Trust me on that one. Trust me, you ain't gonna get it over me. You guys know what I mean? He's seen it 25 years. Oh, yeah. All right, so there you guys go. You should know that, right? What if you had your test today? What about this example here? We'll give you guys a very, well, it's not very simple, but, well, it is kind of simple. What if they give you guys this one? We've seen this last time. I can't remember. Did we put -2? We actually seen this last time. What do you guys use on this one? What do you guys use? You want to recognize what this is. How do you recognize it? Because you did the homework. What do you guys use? Which one? The root test? Use the what? It's a geometric series. How do you know it was on the what? That was on the homework. Do you guys remember the homework? It's a geometric series. Is that right? What was R? It's x minus 2. When does a geometric series converge? When the absolute value of R, which is the absolute value of x minus 2, is less than 1. This is what you have convergence. So you may say to me, how do I know these things? Because you spent time on the homework. If you didn't and you copied from a solution manual, right? Then you didn't spend time on the homework. You spent time copying from a solution manual. And then that's going to hurt on your final. It's going to be painful. So what do you guys do with this part right here? What do you guys know? Yeah. What does that mean again? Do you guys remember? It means what? -1 less than x minus 2 less than +1. So you want to add 2 now to the middle, the right, and the left. So here's the deal. 1 is less than x, which is less than 3. So this is going to be my interval of what? Of convergence from 1 to 3. Is that right? But let's see if you're really awake with this. Let's see if you're awake. Do I check the endpoints? Do we check when x is 1 or x is 3? Why not? Right, because the R will converge here, or we should say the geometric series converges only if the absolute value of R is less than 1. Only then. If it's 1 or if it's greater than 1, we got divergence. So you're strictly using the geometric series test. So we've seen that one, right? Okay, so then you're done. There's your interval of convergence. It's from I is going to be from what? 1 to 3. That's the interval. Okay, and then, ladies and gentlemen, you might say, let me see if you guys know what to do with this one here. Because we got x to the n over natural log n of n. And you can actually see it this way too. Maybe that's a tip off. Let me give you guys a big hint here. What do you guys think this would be? You're going to use the what? The root test. Yes. So that whole thing is going to be an, right? So you have the nth root of the absolute value of an. So this is the nth root, the absolute value, x to the n, natural log of n to the nth power here. So let's go over the algebra. So the algebra here is x over natural log of n. This is to the nth power. Absolute value. You guys remember this is product rule? So it's absolute value of x, natural log of n, product rule. This is the n there. And if you said, what if I have the nth root? Well, then that gets rid of my radical. So then this is the absolute value of x over the natural log of n. And by product rule again, you get the absolute value of x, absolute value natural log of n, and n is positive. So this is the absolute value of x over natural log of n. So that whole thing is what you're going to have to take that limit of. So the limit of that absolute value is the limit. I think I got to tighten this up. So what do you guys do with this? Bless you. What do you guys do with that? Don't you pull it out? Absolute value of x, limit, n goes to infinity, 1 over the natural log of n. What do you guys know about this limit now? This equals what? 0, which is less than 1. That's what you care about. That happens for what? That happens for all x? Right? So if it happens for all x, what's your, isn't that all real numbers? Interval of convergence is from negative infinity to infinity. Oh, let's try this one here. See what we have. Negative 2 to the n over square root of n, x plus 3 to the n. So what test do you guys think you want to use here? Anybody have an idea? What should you use for this ratio test? Why not the root test? Yeah, you don't have n for every term. That power of n for every term. So, again, if you said, I'm worried about time, okay, here's what I would do. Okay, isn't that going to be negative 2 n plus 1 x plus 3 n plus 1 over square root of n plus 1? Okay, then multiply by the reciprocal, right? You say, what's the reciprocal? This is square root of n, negative 2 to the n, x plus 3 to the n. Okay, use some algebra. Negative 2 to the n times negative 2, x plus 3 to the n, x plus 3 square root of n, square root of n plus 1, negative 2 to the n, and this is x plus 3 to the what? Nth power here. So, at this point, I would say you do what? Cancel. Cancel. And then what is left here, it looks like these terms are left. Absolute value negative 2, x plus 3 square root of n over square root of n plus 1. Now, I want to remind you guys that the variable here is what you leave under the radical, this x plus 3. Everything else is going to come out because, well, if you take the absolute value of 2, that'll be 2 square root of n plus 1, because these terms here, these are positive here. Okay, n's a nice what? Natural number, so they're positive. The only thing that's going to be left within an absolute value is this x plus 3. So now, as you take the limit of that ratio, you say this is 2 square root of n Remember what comes out as a constant. The number 2 comes out. Absolute value of x plus 3 comes out. So you have 2. Absolute value of x plus 3. Those are constants. Limit. And then you want to determine what happens with this limit over here. You guys know where that limit goes to? I think that limit goes to 1. Is that true? So you get 2. Absolute value x plus 3 has to be less than 1 for convergence. But we need an interval. So remember, this is not less than 1/2. And now we can say what? Negative 1/2 is less than x plus 3, which is less than what? Positive 1/2, right? So do your arithmetic, solve for x. I think this is negative 7/2 less than x. I think that's negative what? 5/2. Is that true? Double check my arithmetic for these endpoints here. I think I'm okay. Negative 6/2, that's a negative 5/2, and then negative 7. So don't forget, though, what kind of test is this? The ratio test. So if it's the ratio test, we got to check the endpoints, right? We got to check when x is negative what? 7/2. And when x is negative 5/2, we got to check this here. Right? So you're going to have to plug in for x for each of these. And what do you end up getting if you do that? What happens to your series, right? You get negative 2 to the n. So you get negative 7/2. Isn't that negative 1/2 to the n when I plug that in? Double check. And negative 5/2, that's going to be 1/2. So this is negative 2 to the n, 1/2 to the n over square root of n. Double check my arithmetic, ladies and gentlemen. And I think this is going to be, what happens with this? Isn't this 1? And this is going to be negative 1 to the n. Is that right? Let me do this. Okay, you guys okay with this here? Now, why did I write this as 1/2 here and not the other one? What do you guys know about this particular series here on the left here? What is this? Yeah. This is a divergent what? Divergent P series. That's what you guys want to know. So we don't include that negative 7/2, okay? So this is not included. And then what do you guys know about this one? This is converges. How do you guys know that converges? By what? What's the test? The alternating series test. Do you guys remember what that test is? This is an alternating series, but the 1 over square root of n, isn't that decreasing? That limit goes to 0? You know, that's the deal. So you include negative 5/2 as an endpoint. Where do I find it? Oh, here. So here's the deal. You include this here. So you might say, what in the world does this all mean? Well, this is what it means. Right? Your interval of convergence is an open endpoint at negative 7/2, but it's a closed endpoint at negative 5/2. So, you know, that's what they're looking for here. Anyway, I wish I had, what do I wish I had here? I wish we were broadcasting online because I do have more examples of what? Power series. Okay, I can show you guys this. Well, let me see. Is it springboard into the next part? So we're just going to do a quick note on some power series. Right, so like another example here, we started from 0 to infinity, -1 to the n, maybe x minus 3 to the n, and then this is 2n over 1 here. Oh, thank you. Let me go here for homework 5. Close. We gotta. That's odd. Okay, so thank you. Started in some questions. Good, good. So of course, power series are going to be on your final. So let's actually, talk about this. They're going to ask, what is the interval of convergence? And so, as you guys know, you're going to use here you use essentially 3 tests: the ratio, the root, and sometimes the geometric. But essentially, it's the ratio and the root test. So in this case, you guys should realize that we're going to use the ratio test, because even though we have 2 n powers, we have to have an n power for every term. If it was an n power for every term, then we would use the root test. So we're going to have to use the ratio test. Okay. So if you are concerned for time, you may say, okay, how do I do this in a timely manner? All right. Well, I would do this. I would start with the n plus 1 term. And then I'm going to multiply by the reciprocal of the an term. And that's the same as doing the ratio. Okay, because it's going to be a complex fraction anyway. Right, so if you're concerned for time, you go, okay, we'll use properties of exponents here. And then over here, just use the distributive property, do some algebra is what we're going to say. So this is all really algebra based. So it gives 2n plus 2 plus 1, which will give you 2n plus 3 but down here, by the way. And then you have -1 to the n, x minus 3 to the n. So take a look here and cancel. -1, oops, that's going to stay. -1 to the n goes away. And this down here is going to be really 2n plus 3 here, so. Okay. Okay, so now again, by properties, this is going to be positive. All these other terms are positive. What gets left in absolute value is just that x minus 3. So you might say, okay, x minus 3 is in the absolute value. And then you simply have the ratio of now 2n plus 1 over 2n plus 3. So then the question is, where does this limit go now? Because we're looking at this whole thing. Where does that limit go? Where does that go as n gets big? Well, this is represented this way. So ultimately, since you're saying, hey, Mr. Judge, time is an issue for me, well, okay. then be efficient with your notation here. Okay, so bring out your constant term. You say, which term is thought of as being constant? Well, this, you get x minus 3, limit, n goes to infinity, 2n plus 1 over 2n plus 3. Now, this limit goes to 1, in case people did not know. Okay, use calculus 1, calculus 2, doesn't matter. And if you want convergence, this whole thing needs to be smaller than 1. So this is smaller than 1 for convergence. And now you're in the, again, using the definition of the absolute value inequality and solving for x. You get 2 less than x less than 4. So anyway, ladies and gentlemen, there you go. So we're almost there. This is the intervals. Now remember, you have to check the endpoints. And so that happens like if we say, okay, what happens when x is 2? Well, plug in 2 now here for x. Okay. I'm going to bring all that stuff down, copy it. And you end up now with 0 to infinity, negative 1 to the n, negative 1 to the n over 2n plus 1. And so you might say, well, what is this going to be? Well, that's just positive 1, by the way. You might say, I don't believe you. Wasn't that negative 1 to the... Add the powers. Properties. And this is going to be 1 to the n, which is just 1. So you might say, what am I ending up with here? This series. So at this point, you might say, well, I don't know if this series what? Converges. Well, there's a couple of things you can use. Use the what? Integral test. Or limit comparison test. Okay, so if you said, can I use 1 over n? This behaves like 1 over n. Yes. So you're going to find that this diverges by the limit comparison test. We've actually done something like that already. So part of this, when people say to me questions, Mr. Judge, how do I identify what I have done or what I need to do? I would say to you, because you worked on homework and thought of this question, and the integral test comes to mind, because part of the integral test was looking at kind of these kind of series. And then we actually looked at a limit comparison test just like this, maybe exactly like it. And that's kind of how you know about how to go about it. You go, yeah, I worked on my homework, right? And that's kind of what springs up to me. My memory is like, oh, yeah, I'd done that before. Integral test, it was on the integral test homework. Oh, yeah, I also did limit comparison test this one. This is, I think, was an example as well in class. And that's what you get when you check that endpoint where x is 2. Now, you got to check when x is 4 now. You check the endpoints. So we're going to plug in 4 here. And when you do plug in 4 for x, notice what you now get. That's 1 to the n. Now that 1 to the n, ladies and gentlemen, this is going to be 1 again. So you say, well, what does this give you? Well, it should ring a bell. Does you guys know what this is? Let me get out the purple. Again, working on homework, this is the alternating series test. That converges by the alternating series test. Okay, you say why? Because Bn, which is 1 over 2n plus 1, goes to 0 as n gets big. So you can even think of the alternating series test with that. And you go, well, how do I recognize that? Because you did the homework on it. That's how that works. And you studied alternating series test. Anyway, all right. Let's try another one, since I can't seem to get enough of these. Hopefully you guys watched that video if you said, I want to see more of these kind of questions. So, oh, I'm sorry. We forgot to finish the question here. So this means include the endpoint of 4 for convergence so that the interval of convergence will be from 2 to 4, including 4. All right, there we go. There's your interval of convergence. All right, same kind of thing here, ladies and gentlemen, by the ratio test. You can't use the root test or geometric. So you're going to have the same thing. Put the n plus 1 term first. Save some time. Multiply by the reciprocal of an. Okay? And then you're going to use some algebra here. Properties of exponents. You're going to use some beginning algebra here. Okay, so just use a little beginning algebra. Then we get to cross things out. Okay, and then we get to see what's left. Remember, this is the only term that's going to be left in an absolute value. All the other terms get to come out because they're positive. So you might say, do I just have that x plus 1? Yes. And then you have n plus 1 over 4n. And that might help you save a little bit of time. Where you now take the limit as n goes to infinity. And you get to pull out the constant term. Absolute value x plus 1. The limit as n gets big. And you can actually pull out the constant 4 as well. And so you just have n plus 1 over n. And you might want to say, well, where does this limit go to? 1 plus 1 over n. And then that limit goes where? To 1. So you're going to be left with now you want this to be smaller than 1, so there's convergence. Okay, and now multiply by 4, and you end up with what? Absolute value of x plus 1 is less than 4. Definition here. Of the absolute value inequality. So subtract 1 from the left, the right, and the middle. So here's our interval now, okay? But we got to check the endpoints again. So you say, well, how do I check? Well, check when x is -5. So go back to the original, plug in -5 for x. So isn't that -4 to the n, ladies and gentlemen? Double check. So at this point, you say, well, what happens here? Double check. Am I? All right. So what does this mean here? By properties here, I'm going to use red. -1 to the n, 4 to the n. Okay? What happens now? Gone. Now, this one too, you might say, Mr. Judge, how do I know how to do this one? Well, we talked about this one even. We even talked about it. It was in our lecture in our notes. Does anybody know about this one? Yes, it's alternating. Yeah. You might say, do I do the test for the alternating series test? And I'll say you can't. Because n is what again? It's not decreasing. So you cannot use the alternating series test. We even discussed this one in detail. So that's how you know, right? So what's the deal with this one? Do you guys remember? This what? This diverges by what method? Because on your final, you can't just guess. Diverge, converge. No. You got to justify it, right? Why does that diverge? Divergence test. Remember this. The limit of -1 to the n is plus or minus infinity. Yeah, does not exist. So that limit does not exist. If the limit does not exist, it diverges by the test for divergence or the divergence test. So we can't include when x is -5. So that's, again, we actually talked about that and went over it. So anyway. Oh, the other one, x is 3. So now you say, okay, what happens when x is 3 then? Right? So replace this x value with 3. So that's kind of like a nice question. That's like, oh my God. Some of these questions are so nice. So now you say, what happens when I plug this in? Well, now that's going to be what? This is now times 4 to the n. And that's just going to be the series. That's just n. Right? So, okay. So what do you guys know about this? What happens now? What is this finite? This also what? This diverges. Why does it diverge? But what does it diverge by? By the what? By the divergence test. So this is all full circle, ladies and gentlemen. Divergence test is something that comes back. So at this point now, we say, what's this? Why does it diverge? Well, doesn't this equal to infinity? That's not finite. That's the reason. So you want to look up the divergence test. And so, ladies and gentlemen, yeah, that's the deal. That one diverges too. So at the end of the day, it looks like this is the final answer for your interval of convergence here. So, all right. So this is going to be just negative infinity to 3. They're open intervals. And then that's the deal. It's x is negative 5, x is 3. They're both divergent at the endpoints. So that's the kind of stuff that you guys will have. Anyway. All right, well, okay. Now, so if we look at this here, let's recall